To solve this problem, we'll have to first draw the free body diagram of the upper block. So here it is. Force of weight is acting downwards, and the value of weight has been given to us here, that is 70. There will be a normal reaction at the surface of contact between the two blocks, and that normal reaction we will take it as N1. And there is a force of tension acting up here, and that tension will be acting at an angle of 40 degrees, that is given here in the question. Of course, all these values will be different for every student, so whatever values are given to you, the same you need to use. Friction is going to stop the impending motion, which is towards left, and hence it's going to be acting towards right. And the amount of friction will be 0.23, which is the value of coefficient of friction, times N1, the normal reaction. So these are all the forces that are acting here. Now we need to form the equations, use the equations of equilibrium here. So first summation of all the vertical forces, and then summation of all the horizontal forces. Using these two equations, we need to find the values of T and the value of N1. So let's go ahead and do that. So we have sigma V. Let's take all the vertical forces. N1 is upwards, hence positive. W2 is downwards, hence negative. And the component of T will be acting upwards, that is T sine of 40, and that has to be plus because it is upwards. Now sigma V is going to be 0, N1 we don't know, keep it as it is. W2 is given, let us substitute that. T as well we don't know, and angle of course is given as 40 degrees. So we need to bring that in the standard format. Let's take it like this: N1 plus T sine 40 equals 70. Call this as equation number 1. Then we need to take the second equation, in which we need to take all the horizontal components. The component 0.23 times N1 is acting right, so it is positive. A component of T will be acting left side, so it has to be negative, and the component itself is T cos of the angle, that is 40. Now sum of all the horizontal components has to be 0. The rest of the things remain as it is because we don't know anything about them. That is equation number 2. Next, we have to use the equation mode to solve these two equations. We have to take the equation x, y, reset all the values. Now we will take N1 in place of x and T in place of y. Okay. So we'll need to find the N1 and T. We'll need to fill the coefficients of N1 and T over here. The first A will be the coefficient of N1 in the first equation, that's 1. Then coefficient of T will be y, so that is sine of 40. So let's put sine of 40. And then the constant value on the other side, that is 70. Let's put 70 into. Then below we have to put the coefficients of the second equation. So once again, first we need the coefficient of N1 in the second equation, that is 0.23. Then the coefficient of T in the second equation is minus cos 40. Don't forget the minus sign. And the third, the constant here in the second equation is 0. So let's put it as 0. So now we are getting x value as 58.668. So this is the normal reaction in newtons. And then once you press equal to again, we will get the value of y, that is 17.62 newtons. So these are the values of N1 and T. These are the values of N1 and T. So let us substitute, so let us put in these values in. As you can see, I have already done that. And then next, go for the next free body diagram. Next, we'll have to draw the free body diagram of this lower block that we have here. Let's go ahead and do that. So lower block, So this is the lower block, and once again we need to take all the forces on this. Okay, first the weight is acting downwards. Weight is W1 and its value is been given to us as 126. Then there is a normal reaction from bottom. Let's call it as N2. Now the force P is trying to pull it in this direction, so this is the impending motion direction. Hence friction will be acting opposite to that. Friction coefficient at all the surfaces we have been given, that is 0.23. So 0.23 times N2 will be the friction here. And since normal reaction at the upper part, that is N1, we found the value of N1, that is 58.68. So the friction that we get at this surface will also avoid the motion. We'll try to avoid the motion. And this is 0.23 times N1, the reaction at the upper surface. So these are the forces. These are all the forces that are acting on this object. Once again, we need to form the equations. Let's go with vertical components first. N2 is acting upwards, hence plus, minus W1 because it's acting downwards, and minus N1 that is also acting downwards. Remaining all forces are horizontal. They will not have any components in this direction. Let's just substitute. Sigma V has to be 0 because it is static. N2 value we already calculated 58. N2 value we are yet to calculate. Keep it as it is. W1 is given as 126. N1 is also given, that is 58.68. So if you come back over here, we'll have to find this, go back to normal calculation mode, and then feed this 126 plus 58.68. So we are getting the value of N2 here, that is 184.68 newtons. Next we have to take sum of horizontal components, and you see force P is acting right side, hence it is positive. The remaining two forces, 0.23 times N1 and 0.23 times N2, are both acting left, so they both have to be negative. Substituting the values, we have sigma h as 0, P is unknown, we can take 0.23 common, N1 value we know, that is 58.68, and here we'll get plus. N2 value we also found over here, 184.68. So that will give us the value of P. So that we need to calculate over here. 0.23 times 58.68 plus 184.68 plus equal to, and that is the solution. So 55.97 newtons. So this is the minimum force required to cause the lower block to move towards right. So let us fill these things in. So here this is the normal reaction at the lower surface, that is 184.68, and then we have the minimum force P required to cause the motion, that is 55.97. Once you have fed all the values, just click on finish attempt and submit all. Once you submit, you will be shown a review of your answers. If it is correct, it will be shown as correct, and if it is wrong, it will be shown as wrong. I've also kept an option of partially correct question, which means if you are making an error of more than 0.5 in plus or minus directions and up to a maximum of 2, you'll be given half the marks for each of these solutions because the error is more. That means you just need to concentrate a little bit more on calculation part. Thank you for watching this video.